A phage is basically a natural predator of bacteria. They belong to a class of viruses. So what a phage does is when it finds a bacteria that it can recognize, it'll attach to that bacterial cell, inject its own DNA, and use the bacterial machinery to replicate itself. So it gets to a certain point where there's so many phages inside that bacterial cell, it signals that cell to then lyse or explode. So all those new phages are released and they go on to infect other cells. So phage therapy works by harnessing that antibacterial property and just taking something that happens in nature all the time and trying to maybe concentrate it or focus it on a certain pathogen. So when we start out the study, we have to get the phages, and we collect samples from those wastewater treatment facilities. The bacteria that we want to target, we kind of use that as a bait. So that allows us to kind of catch these viruses. You can take a petri dish and you put what we call a lawn of bacteria on it, and you can drop your phage samples on there. And when the bacteria grows, if the phages aren't there, you'll see a lawn of bacteria, it'll be opaque. So if the phage is there, you'll start to see these little tiny holes, and they get bigger and bigger as the phages replicate, and they form these clear, we call them plaques, but they're clearings of the bacteria. We use phage therapy in a couple ways. When we started, we used them in live animals. So a lot of animals can have different types of bacteria in their gut. They don't really cause a problem, like salmonella, but they can take those into a processing facility and they can get on meat products. So we got to the point where we could actually just mix it into their feed, and they would eat it for a few days before they would go to the processing facility, so they don't bring them into the processing facility and then decrease the likelihood that they get on meat. What we've recently done is focus our attention more on actual food products. So we're looking at ground beef and leafy greens, which are becoming more associated with different foodborne pathogens and illness outbreaks. And we found that in many cases it's really pretty effective, especially with spinach. You know, it's reducing it 99.99%. So that's a pretty good reduction. When people hear virus, they sometimes have a lot of questions, and rightfully so. These are organisms that target bacteria very specifically. They don't recognize our cells. We compare it, it's similar to, you could say it's similar to using probiotics in your food. You know, we put bacteria in different products and to help with digestion or whatnot. So it's a very similar idea. It's using a beneficial microbe. Phages, they're probably not a panacea and solve every problem, but if you couple them with other types of intervention strategies that are already existing, you can dramatically and significantly reduce the amount of contamination. So I'm confident that with some further research and the requisite safety trials and whatnot, that phage therapy will become more popular.